Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on digital communication. For digital communication, it is very important to understand what is throughput. Throughput means that how much data can be transferred from the transmitter to the receiver. There are various ways to describe the throughput. Over here, I will do a deep dive for you to understand what is actually bit rate, symbol rate, which is also known as baud rate, channel rate, and last but not least, data rate. From here, you will be able to distinguish all these different to describe the throughput. This will be the objective of this video. Guys, this is my email. If you have any question regards on this discussion, please drop me an email, okay? Or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Just give me a few seconds. Help me. Press the like button now. For those who are new to this channel, and if you want to encourage me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. The first one that I'm going to explain will be bit rate. What is actually bit rate? Okay, so bit rate actually represents the numbers of bits. Okay, it can be binary 1 or even binary 0. How many of them can be transmitted or even processed in a second? The unit to describe bit rate will be bits per seconds. Okay, but nowadays we are sending millions of bits. So therefore we have these common multipliers like kilobits per second, megabits per second, or even gigabits per second. Coming to the key point, okay, bit rate is actually the fundamental measures of raw information capacity. Okay, so it is what you usually see as internet speed. Okay, so basically internet speed actually refer to bit rate. How can we actually understand the meaning of bit rate? Okay, for example, we need to count the numbers of bits, whether it is 0 and 1. Later on, I will give you an example. Okay, so regardless how they are grouped or how they are actually modulated. Okay, let me give you this example now. Let's say I can send this amount of data in 1 second. Okay, so we need to count the numbers of bits. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore, from here, we can say that the bit rate is 12 bit per second, which is described over here. So this is the meaning. We can just count the numbers of the digital bit, whether it is 0 or 1. Okay, so let's say in 1 second, then we can describe them as 12 bit per second. So this is the equation that I mentioned to you earlier on. Okay, so basically the bit rate is equals to the number of bits, okay, that basically transmit. Like for example, earlier on I just count, okay, against the time. Okay, so earlier on I give the time in terms of 1 second, but over here you can always give the time, let's say like 1.5 second. But if you want to describe as a bit rate, I suggest you to convert to 1 second. So the simple analogy will be the total numbers of individual letters being sent down a pipe each second. Okay, so imagine this. Okay, so for this bit rate, is you write a letter, so every single letter that is actually sent down a pipe every second. So this is actually for the bit rate. Next will be symbol rate, which is also known as baud rate. What is actually a symbol rate? So a symbol rate actually describes the number of symbol or maybe the signal change that are actually transmit in 1 second. Coming to the unit, okay, you can actually describe the symbol rate as the numbers of symbols that can be transmitted every second. So later on, I will give you an example to understand this better. So this is also known as the baud rate. Coming to the key point, okay, so basically a symbol is a distinct state of the communication channel. For example, you can modify the amplitude, okay, which is the voltage level. You can modify the phase or you can modify the frequency. Okay, so later on series discussion, you will be able to understand this better. For example, ASK, FSK, and PSK. So each symbol can actually represent more than 1 bit. Okay, can be represented by 1 or even more than 1 bit. Coming to the formula, this is how you can compute the symbol rate. Okay, so it will be the same as I described earlier on on the bit rate. So basically, you need to count the number of symbol that is actually transmit over the time. Let's say you keep the time again to 1 second. You need to count the numbers of symbol that you actually can transmit. So later on, I will give you an example. How does symbol rate actually relate to bit rate? Okay, so basically you can see from here, this is actually the equation, okay, that relate the symbol rate to the bit rate. Okay, so I will explain a little bit more on this equation here. So this will be the log 2m. The m is actually the number of distinct symbol. Let me give you an example. For example, QPSK. Okay, the Q actually stands for quarter. Quarter means 4, which means that I'm going to have m equals to 4 symbol. And therefore, from here, you can see that this log 4 over log 2, okay, is actually equals to 2. This simply means that, okay, each symbol actually carry 2 bits. As you can see from here, this is 2, which means that 2 multiplied by the symbol rate is equals to the bit rate, which means that each symbol actually carry 2 bits. Okay, so let me give you an example. For example, if let's say the symbol rate is 1000 symbol per rate or baud. Okay, so how I relate this to bit rate? Okay, so I can relate to the bit rate as 2 multiplied by 1000, which is equals to 2000 bits per second. This will be for the bit rate rather than the symbol rate. So over here, okay, I hope you are not confused. How can we actually describe whether it is baud rate or bit rate here? Let me give you an example for you to understand better. So this is what I have described earlier on the bit rate. I just count the numbers of bits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from here, I can say that the bit rate is equal to 12 bits per second. Okay, so now, for example, okay, I'm saying this one symbol, okay, basically make up of 4 bits. Okay, so I can regroup this again. Okay, so basically 4 bits over here, they become one symbol. 4 bits over here, they become another symbol. Again, over here, 4 bits become one symbol. So now I will ask you, what will be the symbol rate? So you can count the symbol rate is actually equals to 1 symbol, 2 symbol, and 3 symbol. So from here, you can say that the symbol rate is actually 3 symbol per second. So this will be for this case here. So over here, you can see that 12 bits per second is equals to 3 symbol per second. So this is the key difference between bit rate and symbol rate. Let me give you some example. For example, if 1 bit is equals to 1 symbol, then the symbol rate will be exactly the same as the bit rate. Another example, okay, let's say if 2 bits is equals to 1 symbol, then the symbol rate will be half of the bit rate. Okay, so with this example, I think you probably can understand what I want to mention over here. Again, come back to this simple analogy. The numbers of distinct envelopes sent down the pipe each second. Each envelope can contain one or more letters. Okay, so for example, for this case here, if you still remember, I mentioned what is on the bit rate. I'm not sure whether you still remember. So for bit rate, the simple analogy will be the total numbers of individual letter. Okay, so basically individual letter being able to send down a pipe each second. How about for the symbol rate? So basically for symbol rate is slightly different. It's basically the number of distinct envelope. So basically from here, you just imagine one envelope can be more than one letter. For example, for this case here, let's say for this case here, which means that 4 bits meet into one symbol, which means that one envelope contain 4 letters. So basically, this is the simple analogies about bit rate and also symbol rate. For bit rate, you can imagine that it's letter, but for symbol rate, you can imagine it is actually envelope, and envelope can contain more than one letter. Next will be channel rate. Channel rate is also known as gross bit rate. Okay, so in fact, channel rate is quite similar with bit rate. Okay, so later on, I will describe the key difference between channel rate and bit rate. So what is actually channel rate? Okay, so channel rate will be the total numbers of bit. Okay, basically for this time round for channel, it include all the useful data and also all the overhead, which means that these are so-called not useful data at all. They are just the overhead. All these actually refer as the channel rate, which is physically transmit on the communication channel in 1 second. It is essentially the raw bit rate as seen by the physical layer. Okay, so coming to the unit to describe channel rate will be also bits per second, same as bit rate. Coming to the key point, okay, so this is actually the speed that you will measure on the wire with an scope. Okay, so it include everything. For example, the useful user data. We also have the header. Let's say we have some form of error correction and also the framing bit to determine the start bit, the stop bit, etc. So a simple relationship between data rate and channel rate is basically by this equation. Okay, so like I mentioned early on, channel rate include all the data. Okay, you can see from here, the data, the header, the error correction, framing bit, in short, total numbers of bits that I can actually send over. As for data rate, is actually on the useful data. Okay, basically will be this point on the useful data. Okay, so therefore from here you can see that the data rate is actually equals to the channel rate, which means that everything that you can send minus away the overhead rate. Okay, the overhead rate can be the header, can be the error correction, can be the framing bit, etc. Coming to the simple analogy, okay, the total numbers of letter, okay, basically you write a letter, basically contain the, let's say the address, etc., etc. So these are so-called the overhead rates here. Let me give you a very simple example to understand the key difference between channel rate and also bit rate. Okay, so basically the meaning here, okay, so basically for channel rate is the actual load on the channel and is constrained by bandwidth and noise. Okay, let me come to this example later on. So let's say, for example, for this case here, okay, I only have one channel. Okay, so therefore my bit rate and channel will be the same, which is 12 bit per second. So now imagine I have three channel now. Okay, so basically my individual channel rate will be still equals to 12 bit per second. However, for my total bit rate for this device will be equals to 36 bit per second. So this is what I want to highlight the key difference. When we mention about channel will be the individual channel. So let's say the individual channel can send 12 bit of data. So now my total so-called throughput of this device. Okay, so for example, my total bit rate for this device will be equals to 36 bit per second. Okay, I come to a very simple example how we actually can compute the channel rate. For example, okay, the data rate is 5 megabits per second. Okay, so if you still remember, data rate means all the useful information. Okay, so for example, we add a lot of redundancy, let's say 25% of the redundancy. So therefore, we can compute that the channel rate is equals to 1.25 multiplied by 5, which is 6.25 megabits per second. So this is actually for the channel rate. Coming to my last one, data rate. What is actually data rate? Okay, so data rate is actually all the useful user data bit. Basically, we remove whatever overhead. This is what we know as data rate. The unit for data rate will be the same, bits per second. Coming to the key point, okay, so basically this is actually the effective speed that you're going to experience for this digital communication. It is always lower than the raw bit rate, okay, which means that data rate is always lower than bit rate and also channel rate because they actually subtract all the non-data bits that is actually used. Okay, so for example, these are we call the overhead, okay, so which I have described earlier on. So basically data rate is equals to the channel rate minus away whatever that is all the overhead. Coming to the simple analogy, okay, so the number of meaningful word, okay, for example, I write a letter, okay, whatever that is meaningful word, that will be count as data rate. Let me give you a simple example to understand this. Okay, so in fact, I have give you this example early on also. Okay, so this is actually the equation. The data rate is equals to the bit rate or the channel rate minus the overhead. For example, for this case here, let's say the bit rate is 10 megabits per second. Let's say the so-called the overhead protocol is actually 20%. So therefore, I can compute that my data rate, which is equals to 0.8 multiplied by 10, which is 8 megabits per second. Okay, so this is actually for the data rate. Key takeaway for the four parameters that I actually described earlier on. Okay, so what is simple rate? Okay, so in short, simple rate actually describe how fast the signal element change can be amplitude, can be phase, can be the frequency. So this is actually for the simple rate. Bit rate actually describe how fast the bit can be sent from the transmitter to the receiver. Next will be the channel rate. Okay, so for channel rate is basically how fast the physical channel is actually used. Coming to the data rate is purely on the useful information. They remove whatever the overhead. So this is actually the key difference between the simple rate, bit rate, channel rate, and data rate. Let me give you a practical example in order to understand the four parameters that we described earlier on. Okay, so basically I will use this Wi-Fi transmission for you to understand this. Imagine, okay, you are actually sending a file over a Wi-Fi connection. They are using this 256 QAM modulation. Okay, so if you don't understand this, don't worry. Okay, so basically they just change the amplitude and also the phase in order to have this 256 QAM modulation. Okay, so coming to the symbol rate, okay, so the radio actually changed its phase or the amplitude to create a new symbol. Like I mentioned earlier on for QAM, basically they will change the amplitude and also the phase in order to have a new symbol. Let's say the symbol rate is 1 million symbol per second or 1 M baud rate. Okay, so basically this is for the symbol rate. Coming to the bits per symbol, okay, for 256 QAM, basically they encode 8 bits into one symbol, which means that one symbol they actually has 8 bits of data, which is over here 2 to the power of 8 is equals to 256. So this is actually for the bit per symbol. Coming to the bit rate and the channel rate, for this time round, they are exactly the same. If let's say we don't describe the different channel, so therefore, if we don't describe the different numbers of channel, which means that the bit rate will be equals to the channel rate. This will be the raw physical layer speed, which is 1 mega baud rate multiplied by the 8 bits per symbol, which means that my bit rate will be equals to 8 megabits per second on this channel. This is only for one physical channel. So this is also known as channel rate if let's say we are going to describe only one channel. Coming to the overhead, okay, so for example, this 8 megabits per second, this stream include the Wi-Fi printable, MAC address, error corrections, and all those retries. Okay, so basically these are all the overhead. As for data rate, it's only all on the useful data. So basically we'll be using the channel rate minus away whatever that is overhead. So let's say for this time round, it is 6 megabits per second. One thing I want to highlight, data rate most of the time, in fact, is not most of the time, in fact, it's all the time, data rate is always smaller than channel rate. So this is what I have for this video. This video, I have described what is symbol rate, what is bit rate, what is channel rate, what is data rate. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.